we're going to start with a new topic today. It's probability. And today's lesson is just a revision of everything that you should know up until now. So, page 1 you have to learn, and page 2 you have to learn and know by heart. You also should know what a deck of cards look like. There are 52 cards in a deck. You have two colors, black and red. And you have 13 types of cards. And there are two jokers. So if I ask you what is the probability of drawing a king, the probability is always how many kings are there out of the total number in the pack. So it will be 4 out of 52 is the probability of drawing a king. Page 1. Then you get the probability formula. You have to hurry. The probability formula is the one that appears on your formula sheet. And if I give you, for instance, a sum with a lot of probabilities in the question, you use this formula to calculate whatever I ask. Like for instance, I say the probability of A or B is 0,2, the probability of A is 0,6, and the probability of A and B is 0,1. Calculate the probability of B. Then you use this formula. Now, the OR in this formula has a mathematical symbol, and it looks like that. And the AND has another mathematical symbol, and it looks like that. So in a question, if I give you that part, you should know that this is OR and that is AND. Good. Mutual exclusive means that the two events don't have anything to do with each other. It's like tossing a coin. It can be kop en staart, what's the heads and tails, or you can roll a dice, which is 1, 2, 3, 4, 5, 6. Do they have something in common? Are they heads and tails, or 1 to 6, something that is the same? No. So these two events are mutually exclusive. They don't influence each other and they have nothing to do. The one doesn't influence the other one. Okay. Then we get to complementary events. That means that if you have two events like this, and I want to know what is the complement of A, then all the other elements will be in B. Or if I ask you what is the complement of B, all the other elements are in A. So nothing is around the circles. Everything is inside the circles, and the one is the complement of the other one. Independent events, they don't influence each other. So if one, let's say A happens, it doesn't have an influence on what happens with B. Now we have three methods of determining probability.
Can you please give an example?
Our first example here. You have 3 blue and 2 green Smarties. You don't eat them. You draw one and you put it back. And then you draw another one and you put it back. So the first draw doesn't influence the second one. But if you eat this Smartie, it influences the number of Smarties left Okay. So if you put it back, it's independent. Right, so let's look at the three methods of determining probabilities. They are tree diagrams, two-way tables, and Venn diagrams. So let's look at tree diagrams when you have independent events. You always, when I give you the little essay, always count how many are there in the total. We have 3 blue and 2 green Smarties, so in total we have 5. One Smartie is taken and replaced by a dom. A second Smartie is taken and also replaced. I wouldn't do that. But determine the probability that a green and a blue Smartie is taken. But you have to read carefully. A green and a blue Smartie. So, with a tree diagram, you always start with a small dot. And then you draw your 2 branches. They represent the first draw. It can either be a blue or a green Smartie. The probability of taking a blue one is, because there are 3 blues, 3 out of 5. 5 is the total. If you take a green one, it's 2 out of 5. Do you all follow? Yes. Okay, so this is the first draw. Now you put it back. Now you draw again. So that's the second draw. If you drew a blue Smartie and put it back, your chance is good to have either in the second draw a blue or a green one. Or you drew a green one in the first draw, so for the second draw you can draw a blue or a green. Okay, that makes sense. And because we didn't take the Smartie, we put it back, the totals stay the same all the way through up until the end. Now what's important, you must always write your outcomes. Always, always, always. How do you get your outcomes? It's blue, blue, or blue, green, or green, blue, or green, green. Now you can answer your question. Determine the probability that a green and a blue Smartie is taken. So it can either be blue-green or green-blue. So in both of those 2 outcomes, I drew a green and a blue Smartie. Do you agree? Right, now you have to write it mathematically. So the BG is the probability of a blue and green, or the probability of green and blue. And is multiply, or is plus. Then you write the branch probabilities, and then you get your final answer, and always simplify your answer. Always, always, always.
Always start with that first item. Is that the way that you want to start?
Yeah.
Yes.
Yes. Our next example is where we draw a tree diagram, but now we have dependent events. There are 6 red and 4 blue marbles, and a marble is drawn but not replaced. A second marble is drawn and not replaced. Just add that sentence. So, if your little sister and your little brother draws a marble, let's say your brother draws first, he draws a marble, he likes it so much that he keeps it, doesn't put it back. And then your little sister draws a marble and she also likes it so much she doesn't put it back. Does the totals change? Yes. So they are dependent events. The next draw depends on what was first drawn. So we start with a little dot and we draw the first draw the two branches, red marble or blue marble. We have 6 red ones and 4 blue ones, and there are 10 in the back. Now we keep that marble. We draw another one. If you drew a red one, the red one total changes to 1 less. But the grand total also changes to 1 less. And to double check yourself, these totals or these probabilities must add up to 1. These probabilities must add up to 1. And these probabilities must add up to 1. Okay. And then you write your outcomes. Now we want to get the probability when both marbles were blue. So we are looking for a blue. So you look at the branches. It's 4 over 10 times 3 over 9 for a blue. Always simplify your final answer. The second question, first one was red, second one was blue. So only the red blue. So it's 6 over 10, 4 over 9. Multiply. Are there any questions? Let's look at the two-way contingency table. This one is the most difficult one when I ask you probabilities, because you have to read very carefully. We have a class of 30 children. How do I know it's 30? The grand total is 30. And we look at the boys and the girls, the color of their hair. Wake up. Either black, brown or blonde. So the first question. What is the probability if we choose a learner randomly who have black hair? Black hair, 8 out of 30. I didn't specify that it should be a boy or it should be a girl. So we take the grand total. The next one. What is the probability if we randomly choose a learner that will have brown hair given a girl is chosen? That part, given whatever, means that you're only looking at them. So I sent all the boys out of the class. I'm only looking at the girls. And who has brown hair? So you only look at the girls. Brown hair is 4 out of 12. And simplify. The next one. Who will have blonde hair given a boy? So I send out all the girls and we only look at the boys. Blonde hair, 4 out of 18. So always simplify. The next one. What is the random chosen learner? What if it is a girl given that it's blonde hair? So I send out all the brunettes and the black hairs and the redheads. Only the blondes stay in the class. So we look at the blonde. The grand total is 10 and it must be a what? A girl. So it's 6 out of 10. Do you all understand this one? Okay. Will be a boy that has brown hair. I don't say only look at the girls or only look at the boys. So we take the grand total and the boy with brown. Boys with brown is 8. D, this one. It will be a girl given that the hair is blonde. So we only look at the blondes. There are the blondes. a girl out of the blondes. Okay? That's how you use, pardon? That's how you use the two-way contingency table. Now we get to Venn diagrams. What? Ask again slowly.
I don't know if you're going to do it, but can you please do an example of how can we see that the hair color of this is dependent or independent, that calculation?
Okay. If I ask that, you must use this formula. You do the left-hand side first, blonde and boy, and you get your answer, and then you do the right-hand side first, second, only blonde, only boy, multiply the two, and if they are the same, then they are independent. Okay, so if I ask you independent events, left-hand side alone, right-hand side alone.
Ma'am, for the E&E, for the goal with that blonde, you use 10. You use the total 10. But for the E with the boy that has brown hair, you use the entirety.
Okay, the keyword was given that it's blonde. So here, I don't give you anything. Then you use the grand total. And then you look for boy brown. So boy brown is 8 over 30. Good. Venn diagrams. There are two types of Venn diagrams. I can give you probabilities that you have to put in the Venn diagram, or I can give you numbers. Like for instance, the first example that we are going to do is probabilities. The probability that Jack drinks a cold drink is 0.6. The probability that he drinks water is 0.3. The probability that he doesn't drink either one is 0.2. So you always start with two circles if there are two events. In this case, it's cold drink and water. And then you write the probabilities. Then you write the probabilities in pencil next to the headings. Cold drink is 0.6, so that's pencil. And water is 0.3, so that's my pencil. And what they give you is neither one is 0.2, so that you write in pen. And you always start a Venn diagram in the center, so where the two circles overlap. That is an X, because we don't know what it is. Alright, so that's an X. We know cold drink is 0.6. So if that part is X, what will this part be? 0.6 minus X. Look at the water. If this part is X and the whole thing is 0.3, it means that that part is 0.3 minus X. And all the probabilities must add up to 1. Okay. Now they want you to calculate X. So we add everything up and say it equals to 1. So it's this part plus that part plus this part plus the outside part equals 1. And then you solve X. So X is 0.1. Then substitute and work out your probabilities. Right. Now they ask, what is the probability that he will drink only one of the two? So it's probability of only one. So it's that part or that part. Only one. This means he drinks both. So we exclude that and we exclude that. So it's either that or that. So the probability of drinking only one thing is 0.7. Do you all follow? Now I want you to add the following Venn diagram example. It's an example where I give you numbers, not probabilities. And you're going to need a round object, either your Pritt or the lid of a bottle or whatever, to draw your two circles. We have 30 pupils, so the number of my sample size is 30. We have maths and we have biology. So we have two circles. One's name is math, other one is biology. And I tell you how many does math, how many does biology, and how many does both. You always start with the center. So you start with 2 in the middle.
In an exam, does it matter if your circles are perfect?
No, not really. So we start with the total number of maths in pencil next to the name and the total number of biology next to the name biology, also in pencil. And the 2 in the middle, in the center, is in pen. So if the total number of children taking maths is 15 and we have 2 that's already in the circle, how many is under my finger? 13. If the total number of biologies is 11 and 2 is already there, how many is underneath my finger? 9. Now we have 13 plus 2 plus 9, that's 24. But there's a class of 30. So where's the other 6? Outside. Baie mooi. Don't forget the outside one. Okay, and then the questions can follow.
I was going to ask you, are we going to get one like in the trick of 3 Venn diagram?
Yes, you can. You always start in the middle, then you try to do the next round, and then the outside one.
It's not a grade 11 machine, it's the meaning of it.
Yeah. Okay, that's all for today. So your homework is exercise 1. Exercise 1 on page 6, number 1 till 9. Mrs.